All right, so I'm going to have to graph the system because there's more than, oops, that 8 should be over here. Okay, I'm going to have to graph because there's two of them. I'm going to graph this first one in orange. I'm going to put a dot on the y-intercept. I'm going to go um, down 6 over 1. 1, 2, 3, 4, 5, 6 over 1. I'm going to draw a dashed line because it's greater than and it's not equal to. I'm going to use a test solution of 0, comma 0. So if I put a 0 in here and I put a 0 in here, I'm going to get 3. Is 0 greater than 3? No. So I can't shade on that side. I'm going to shade on this side. Let's take a look at this next one. I'm going to do it in red. -2 for my y-intercept. And then it says -1 over 1, basically, right? Negative x is -1 over 1. It's going to be down, let's do it right here, down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over, up 1, backwards 1, up 1, backwards 1, up 1, backwards 1, up 1, backwards 1, up 1, backwards 1. It's a solid line because it's equal to. And then we use my test solution. So my test solution, I'm going to plug in a 0 and a 0. 0 greater than equal to -2. Is that true? Yes. That means I'm going to have to shade, let's use green, everything where the test solution is, everything above. Now, do you see where it overlaps? I got the green and yellow. You need to shade that as dark as possible so that I know that you know that the solution falls in this area. All right, this is exciting. We get to finally do a word problem with systems of inequalities. So take a look at this one right here. I'm going to write two equations. I have uniform and I have uniform pants and I have uniform shirts. So let me erase that, uniforms. We have pants and shirts. So we have pants and shirts. So we have P plus S and P plus S. If the pants cost $12 and the shirts cost $8, and Jenna wants to spend less than $48, she's going to spend less than. She can't spend more than 48. She has to spend less than. She could spend $48 though. So I'm going to write equal to. What are two combinations of what Jenna could buy? Okay, so this is not a system actually because they don't say how many of each does she buy or anything like that. So it's just going to be one. So that's what you write. But now this is the problem. It's not set up where y equals um, mx plus b. So we're going to have to subtract 12p on both sides. $8s is less than equal to -12p plus 48. Now, divide by 8 on both sides. S is less than equal to, what's -12 over 8 simplified? Well, I can divide both of them by 4. So it's going to be -3 over 2p 48 divided by 8 is going to be 6 plus 6. Okay, so now I can graph this. So let's give that a try. I'm going to start with a 6 on the y-axis. I'm going to go down 3 over 2, down 1, 2, 3 over 2, down 1, 2, 3 over 2. It's a solid line because it's equal to. Okay, I'm going to use a test solution. I'm going to use 0, 0. I'm going to use 0, 0, so that's going to be 0 is less than equal to 6. So, is 0, 0 a solution? 0 is less than 6. So everything, including this point, gets shaded. So that means I'm shading to the left of my line. So possible solution could be 2 comma 2 or 1 comma 4, right? Tons of solutions. The only tricky thing is, let's just make sure if I name this my y, this is my x, so that this would be S comma P, S comma P. So 1 shirt, 4 pants, or 2 shirts, 2 pants is what she could buy.